Let's solve problem F17-2. An 80 kilogram cabinet is allowed to roll down an inclined plane. Determine the acceleration of the cabinet and normal reactions on the pair of rollers at A and B that have negligible mass. So let's start out with acceleration. To do acceleration, let's do a free body diagram of the cart. And I'm going to rotate my axis, X and Y, because my component in the X-axis is going to cause my acceleration. My component in the Y direction here will be equal to the normal. So if we rotate it, I think it'll be easier. And let's draw this over here. I have mg straight down, which will have a component along the plane and a component perpendicular to the plane. And that component will be mg sine of 15, the angle 15. So if I sum the forces in the x direction, I've got mg, we could do negative mg, but we know what direction it's going, sine of 15. And that's the only force. The normal forces are perpendicular, therefore have no x component. And so we know that mg sine 15 will be equal to ma. M's cancel. And a is equal to 80 sine 15, which is equal to 2.539 meters per second squared. Alright, and I'm just going to designate it that direction so we don't need the negative. I'll draw it there. Okay, so the second part of the question is, what is the normal reactions A and B? So I'm going to find these by summing the moments about G. If we sum moments about G, we're going to get 0. And so we have the normal at A times 0.5, and that is causing a positive rotation, minus the normal at B, which also has a direction or a distance of 0.5, and that will be equal to 0 again. So the normal at A is equal to the normal at B, which will be equal to 1/2 mg cosine 15. That is, this one here is mg cosine 15. And since A and B are equal, they're each going to have 1/2. Because if we sum the forces in the y direction, NA plus NB equals mg cosine 15. So each one takes half. And so that is equal to 379 newtons. Now, let's try solving this a different way. Let's solve it where we sum the moments when we calculate the normal reactions. Let's sum the moments about B. Okay, so if we sum the moments about B, we have NA times 1, still causing a positive rotation. I'll take the y component of mg, which is, and that's going to cause, that y component is going to cause a negative rotation. So negative mg cosine 15, and that's times 0.5. And then I'll take the the x component of mg, which is mg sine 15, times 1.5. And that equals 0. Now if we substitute in all the numbers for NA, we don't know NA, and we know MG, if we put all that in, we get NA is equal to oh, sorry, I summed it about in NA. So let's do NB. If we sum about A, we'll get NB. And that's negative. Now we have NB is equal to 683. Now you're like, that's not correct. So what went wrong? Well, it's not actually, we went around A, we summed the moments around A, and we said that equals 0. But the truth is, at this instantaneous time, it is rotating about A. It is accelerating about A, because we have an acceleration in this direction, so that acceleration is causing an acceleration about A. We could just take that acceleration and multiply it by the distance r, and we have the acceleration. So instead of making it equal to 0, what we want to do is make it equal to the mass times the acceleration times the distance r, which is up there. So this is going to be 1.5. Now if we put all that back in there, we get NB is equal to 378. There's 379.